Today we're going to qualitatively examine an object's motion by using motion graphs. So we're going to be interpreting motion graphs. This is a visual way for us to represent an object's motion. Okay, when we set it up, we're going to have, most times when we think of motion, we think of objects as moving along some kind of number line, with the initial position here, and then maybe it moves here, and then maybe it goes to here, something along those lines. Okay? If we want to represent where the object is with respect to time, we need to add a second axis. Okay? So we're going to take this position axis and we're going to put it on our y side. So position will be here. And we're going to add in the time aspect. So our time component will be along this axis. Okay? If we wanted to graph these positions, x0, x1, x2, x3, we will label them on our y-axis, okay, which is kind of counterintuitive, but whenever we make graphs with respect to time, time is always going to be on our horizontal axis. So we set this up. X initial will go right here. We'll put x1 a little bit above it. Okay, x2, there's a pretty big gap between, so we'll move x2 way up here. And then we'll put x3 just a little bit above x2. Okay? Say we had some time periods, and our time periods we want to make pretty much even across the axis here. So we'll put T1 here, we'll try to make it as even as we can. We'll put T2 here, again, try to make it as even as we can on this axis. And we'll put time number 3. Okay, so now we want to graph its position at these different points. Okay, and if we were to show a graph of that object, which you travel, it's something like this. Okay, that's assuming that's moving at a constant velocity. Okay, if we were to put our axis up again, our position, our just generic position versus time graph, and we want to talk about the slope that if we're going to take. Okay, so let's say we have x1 is here, x2 is here. Let's say time 1 is right here and time 2 is right here. If we make a graph, or a line I should say, from x1 to x2 at t1 to t2, and we want to find the slope of that line, we would say, our just generic slope equation is delta y over delta x. Okay, well what's on our y-axis this time? That's right, it's position. So it's really going to be delta x up here because it's changed in position, which we call displacement. And on our x-axis, it's delta t. Is this familiar to something you've seen before, this equation right here? Delta x over delta t? Sure, we don't really use the delta in front of the t, but this gives us an equation for our velocity. So anytime you take the slope of a position versus time graph, that gives you an object's velocity during that time period. Okay, so it's very important to remember that. We have a few different shapes that we're going to examine here for position versus time graphs and talk about how an object moves or doesn't move when you see these specific shapes. The first we're going to look at is a nice flat horizontal line. Okay, assume every line is straight. I'm drawing these by hand, so they're going to be a little bit crooked at the end, like this one is. Okay, so I can hopefully make that a little bit neater. Clean that up a little bit. Okay, so a nice flat horizontal line. If we call this position x1, how is position changing over time? You're right, it's not changing. Okay, if we were to look at the object's position at x1, it's still, or at t1, it's still at x1. At t2, still at x1. At t3, still at x1. At t4, still at x1. So what is our object, or how can we describe our object's motion for this shape on a position versus time graph? Exactly, the object is at rest. Okay, so we would describe our object in this case as being at rest. So when you see that horizontal line, you know that the object is at rest. If you think of it in terms of the slope, what's the slope of a horizontal line? Well, The slope is 0. And we said before that slope equals velocity. So if the slope of our line is 0, then we know the velocity of our object is also going to be 0. Okay? So keep those things in mind. You can think of it in terms of looking at the motion, or you can think of it in terms of the slope, however you're comfortable doing it. Okay? Let's look at our next shape. Our next shape is going to be a nice straight line with a positive slope on it. Okay? So let's look at this in terms of the distances traveled. Okay, so here's T1. It's going to correspond to a distance of x1. T2 is going to be x2. Okay? Again, trying to do this as best I can. Okay, x3, then T4, x4. Okay? Look at these displacements. Okay, from x0 to x1, from x1 to x2, from x2 to x3, and then from x3 to x4. What do they look like? Exactly, they're the same displacement. Okay, so looking at this graph, we can see that our object is covering the same amount of distance in the same amount of time. So anytime something is the same, we say that it is constant. Okay? Is our object moving further away from its initial position over time, or is it getting closer back to where it starts over time? Okay? It's moving upward, so upward we know it's going to give us a positive slope. And if it's moving greater distances away, we also know that it's going a positive direction. So anytime you see a positive slope straight line, we describe that object's motion as having a positive constant velocity. Okay? And if you were to take the slope of it, it would be a positive constant value. Okay? So keep that in mind. Slope or just general shape of the graph. Okay? Let's look at if it was a negative sloped line. Okay? So in this case, our object is going to start up here. Okay? We'll call that x0. So we figure out where x1 is. It's roughly right there. Okay, x2, we're going to say is right there. x3 will be here. And x4 is right here. Okay? Let's look at our displacements here. So again, from x0 to x1, is that going to be that value right there? That's the delta x. From x1 to x2, there's your delta x. From x2 to x3, there's your delta x. From x3 to x4, there's your delta x. So as we see again, our delta x's are going to be the same. However, our object is moving back in the opposite direction. Notice that the general shape of our line has that downward slope to it. Okay? It's going downhill. So we know the slope of this line is going to be negative, and our object is moving back in the other direction. So whenever you see a line that's a straight line that has a downward slope on a position versus time graph, we can describe that object's motion as having a negative constant velocity. Okay? So we'd say that this object has a negative constant velocity. The slope of the line, again, is a constant negative value. Okay? So those are our shapes when the object is traveling at a constant rate. It's either nice flat horizontal, which means that it's at rest. If it's a positive sloped line, straight line, then it has a positive constant velocity. And if it's a negative straight line, then it's a negative constant velocity. Let's examine now when an object does not travel at a constant rate. Instead, it is accelerating. Okay, we'll talk more about acceleration later in the week. Let's just talk about it in terms of a general sense now. Acceleration is when an object's velocity changes. Okay, and there's three ways for that to happen. Speeds up, slows down, or changes direction. We'll be looking at two of those today in terms of objects speeding up or slowing down. first thing we're going to look at is a nice upward exponential curve. Okay? How is this different than the other ones we've seen so far? Exactly, it's curved. Okay, so when the graph is curved, okay, so when it's curved, velocity is not constant. Therefore, there is some kind of acceleration. Object is speeding up or slowing down. Okay, so let's examine this and see what the object is doing. Okay, this is pretty straightforward. You've seen this kind of graph before. Okay, let's look at these positions over time. So x0 is down here, x1 is here, x2, x3, and x4. What do we see about our displacements? Okay, well, initially from x1 to x0, not very far. Okay, from x1 to x2, we're going a little bit further in that time period. From x2 to x3, still a little bit further. And then from x3 to x4, we're going even further. Okay, so as we can see, we're covering more distance in every time period. And the time periods are the same. Okay, from 0 to t1 is the same, from t1 to t2 is the same, from t2 to t3 is the same time, and from t3 to t4 is all the same time. Okay, so we're covering more distance over time. So if we're covering more distance over time, or our displacements are greater over time, what do we know about our object's velocity? Exactly, it's getting faster and faster. So the way we'll describe our object's motion for a nice upward curved line, where it goes here and curves upward, is going to be a positive increasing velocity. Okay, it's getting faster and faster over time. Still going in the positive direction. Okay, remember our positive direction is upward. So it's in the positive direction, and it's getting faster and faster. Oops. Sorry about that. Okay, now let's look at a shape, another curve shape. This time, I like to call it the humpback shape. Okay, it looks like the back of a whale, or like Quasimodo. So looking at this, okay, we have time 1 here. Okay, it's curved again, so we know that it is going to be a non-constant velocity. That means the object is speeding up or slowing down. Okay, so hopefully we see that the object is doing what? Okay, right, slowing down. How do we know it's slowing down? Well, we said before that when our displacements are getting bigger and bigger, that our object must be speeding up. In this case, our displacements are getting smaller and smaller. See, from x0 to x1, from here to here, is a very large distance. From x1 to x2, you get smaller. From x2 to x3, it's even smaller. And then from x3 to x4, it's just that little tiny section there. Okay. What about our direction, though? Yeah, we're still getting further and further away. You see that x1 is further away from x0, x2 is still further away from the origin from x1, x3 is further away than x2, and x4 is further away than x3. So we're still going in the positive direction, but our object is slowing down. So we're going to say that our motion for this shape on a graph is defined as positive, but a decreasing velocity. Okay, positive, but decreasing velocity. All right, just 2 more shapes, and we'll finish up here with these. And these 2 are a little more difficult because now we're changing direction. All right, we're coming back the other way. So the first one we're going to look at is going to be a shape that looks like the mirror image of that humpback. Okay, now we're coming back the other way. Our object is going to start up here at x0. Okay, this thing going to be at x1. Now it's at x2. x3. And there's x4. Okay? So we know that it's going to be negative because its slope's going the other way. Alright, so the first thing we know is that it's going to be negative. Now we need to figure out the object is speeding up or slowing down. Speeding up and slowing down is just based on speed. Is it covering more distance in every time period? So let's look at that real quick. All right. So here from x0 to x1, very small distance. x1 to x2, a little bit more. x2 to x3, even more. x3 to x4, even more. So is our object speeding up or is it slowing down? Okay, it is speeding up. It's covering more distance every second. All right, that's a very difficult one for people to think about because you see, oh, well, it's getting more and more negative. Well, that's true. It is getting more and more negative. But the negative, that just tells us the direction. Okay, remember, direction is part of our vector quantity. And positive, negative just mean direction. When we see it getting steeper and steeper and steeper as it goes down, okay, and as you can see, it's like imagine yourself on a roller coaster. You go here, slower, 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 and as you go down that incline, that hill, you get faster and faster. All right, so we have that negative but increasing velocity. All right, one more shape, one more shape, one more shape. So let's make one that looks just like this. Okay, so the mirror image of that first curved line we put up there. Our object's going to start up here. We'll say that's x0. Okay, x1 is here. x2 is here. So we're just making these corresponding positions, just like we did before. Right, x3. And then way down here is x4. Okay? What do we see about our positions here? x0, oops. From x0 to x1 is a large distance. From x1 to x2, it gets shorter. x2 to x3, a little bit smaller. x3 to x4 is even shorter. Okay? So we can describe the motion here. We know it's negative, again, because it's going back that opposite direction, that downward general slope. Okay? But it's negative, but decreasing speed. It's getting slower and slower. It covers less time as you go through a negative but decreasing speed. All right? All right, let's look at an example real quick here. And we're going to make a corresponding velocity versus time graph for our position versus time graph. So I'm going to label my axes. Okay, we're going to make this one position. We're going to make this one time. We're going to make this one velocity. And we'll make this one time. Okay? Let's go ahead and make, I'm just going to draw a general shaped line here, and we'll see if we can make the corresponding velocity graph with it. So it's going to start here, okay, a little curved section there, a little straight section there, a little curved at the top, go straight across. See if I can make that one a little bit better, a little straighter, okay, and then we'll have a line that goes straight down. All right, so now we're going to make the corresponding velocity versus time graph. I'm going to label these sections for you right now. When you start doing these on your own, they're not going to be labeled, but I'm going to go ahead and label them as different sections. So section A, B, C, D, and E. Okay, so the lines there, you can tell when the shape changes. So when you take calculus, you'll talk about how the concavity of a line. Okay, that just tells you what direction is it, point up or down. All right. So looking at this, we'll have section A, B, C, D, and E. And I'm going to describe, just like we did before, the object's motion based on that shape. So A, we know it's going faster and faster, and it's in the positive direction. So our description of part A will be positive, increasing velocity. Okay? Part B, we're going to assume that's a straight line. That's a pretty straight line. That's going to be a positive, constant velocity. Part C, still going the positive direction. We're still going further away than we did before. But as we see, we're going slower and slower. So part C is a positive but decreasing velocity. Part D, horizontal line. We know our object is at rest during that time. And part E, negative but straight line. So it's going to be a negative constant velocity. So now we're going to graph that on our velocity versus time graph. And this is the first time we've done it. So hopefully we can kind of figure it out here. All right, if it's positive and increasing, we know on our velocity versus time line that it's going to be positive. Okay, so this is going to be positive velocity, this is negative velocity, and increasing. So it's going faster and faster and faster during that first time period. So we're going to call that part A. B, positive but constant. If an object's velocity is constant, what is it not doing? Exactly, it's not changing. So we're going to have a portion of our graph that's positive, but the numerical value is not changing. Okay? Part C, the object is still moving positively, so its velocity still has a positive value, but it's going slower and slower. Okay, so it's going to go right here. Alright, so see that it's still positive. Our velocity is going from maybe positive 2 to 0. Okay, still in the positive direction because it still has a positive value, but it's slowing down. Okay, it's covering less and less ground every second. Part D, it's at rest, so it's going to be right there along the axis. And then part E, it's negative but constant. All right, we said before that part B was positive constant. Oops. And part C, if it's going to be, or part E, I should say, if it's negative constant, then it's going to be a nice straight line down here, negative, right here. Okay. And if you want to do a little line for like a piecewise function, you can, but you don't have to. Okay. However you want to look at it. All right. So hopefully you have a better idea about motion graphs, relating them to velocity graphs. We'll work on some more in class, and hopefully get a little more comfortable with doing these labs or these kind of graphs. Thanks.